Hello everyone, welcome to EduSure. So today we are going to learn something very interesting about sets, where we will learn whether we can count the number of elements in the set or we cannot count. So in a broad way, we will be discussing countable and uncountable sets, which are very simple to distinguish, and that is what we are going to learn by the end of this class. Okay. So first of all, we should know what is a set. So for example, we are dealing with sets in our daily life since we are small children. So a kitchen set or a dining set or a doctor set when we are 4 or 5 year old. So set means a collection of similar kind of objects. Or if you grow up as big girls, a jewelry set, something like that. Okay. So what is a set? A set is a collection of some kind of elements satisfying certain properties. So when we talk about sets in mathematics, generally it is a collection of numbers, or it is a collection of matrices, or it is a collection of particular kind of functions. But when you're dealing with, a BA honors in economics, so when we talk about sets, it is generally the collection of elements. Okay. So elements are numbers, all right, or some variables satisfying some particular kind of properties. For example, let A be a set containing 1, 2, 3, 4, 5. So we represent elements inside set by using curly brackets. That is the standard terminologies. Also, the elements of the sets are separated by commas. Also, one element cannot be written twice. Also, the ordering is not important. That means I can also write this set as 5, 4, 3, 2, 1. So this is what you should know about sets for this class, for understanding this class. Okay. So then we can also have the set of natural numbers as 1, 2, 3, 4, 5, and so on. So in set A, you can see that the number of elements are finishing at the fifth number. So there are 5 elements in the set A, but if you look at the set of natural numbers, they're not finishing. So I have written small dash. Okay, that means it goes on, the set will not finish, the counting will go on, and that is how we understand how to count the numbers. We have done that in our real number class. Now, so the first concept that comes to us is cardinality of a set. Okay, what is cardinality of a set? Cardinality of a set is number of elements in the set. Okay. So if you look at cardinality, that is NA, it is represented by N bracket A. So cardinality of the set A is 5, while the cardinality of the set of natural numbers is infinite. Okay. So you will say that A is a finite set, and you will say that B is an infinite set. So B is an infinite set. Here B is natural numbers. So infinite set, but we can count. What do you mean by we can count? So I can count 1, then I can count 2, then I can count 3, then I can count 4, and so on. But suppose somebody asks you that write all real numbers, write all real numbers between 1 and 2. Will you be able to write? They look very close to each other. So this is 1. So we are not including 1 and 2. Between 1 and 2 means whatever is falling between 1 and 2. You will never be able to write the number of elements or all real numbers between 1 and 2. Why? Because of the well ordering properties of real numbers. What do you mean by well ordering property? Or because of the density of real numbers. Because if you say, okay, let me choose 1.1 after 1, somebody will say 1.05. Somebody will come up with a smaller number. Somebody will again come with this. So whatever number you choose after 1, whatever number, somebody else will choose a smaller number than that, because the set of real numbers is continuous. After a real number, there is no gap. You immediately get another real number. And that is why you will never be able to count all real numbers between 1 and 2, though it looks very small. Okay, so just see this. You have one thing, which is the set of natural numbers. Okay, 1, 2, 3, 5, and so on. And you have another set. Let us call this set B. This is the interval 1, 2, where all real numbers between 1 and 2. Now, if you look at the set of natural numbers, it looks so huge. You can say 1 crore, but you can say 1 crore 1, 10 crores, 10 crores 1. So there is an order. You can count. But if you look at the set B, you will never be able to count. So this is the introduction of something known as countable and incountable or uncountable. So what is a countable set? A countable set is the one whose elements whose elements can be enumerated. Enumerated means they can be given certain positions. For example, you can say of 1, then we have 2, then we have 3, then we have 4, then we have 6. So you can pick 1, 2, 3, 4, 5, and so on. That is called a countable set. And what is an uncountable set? The uncountable set whose elements cannot be enumerated. Okay, I will never be able to tell which number comes after 1 because there are so many of them. Whatever I pick, somebody else will give me a smaller number than that. So that is the difference between countable and uncountable set. So you can see that both N and B are infinite sets. So, okay, both are infinite. Infinite means the number of elements are not limited, but infinite sets are also divided into two categories: countable and uncountable. Now, these are very important for your preparation for your general knowledge because you might end up getting a question where you will be given a set and you will have to categorize it into countable or uncountable. So you should understand that uncountable and countable are subcategories of infinite set. All the finite sets are countable because they are finite, so we can count them. So there is no question over there. But whenever we have an infinite sets are divided into two categories, countable and uncountable. So an uncountable set is always bigger than a countably infinite set. You can see that this particular interval 1, 2 is going to have more elements than the set of natural numbers. That is the beauty of mathematics. This looks so small and still it is bigger. Why? Because this is dense. Dense means between any two real numbers, there will be another real number. So no matter how small the difference is, for example, you choose 1.01 and then you choose 1.02. Now there is a difference of 0.01, but still you will have infinite numbers between those two real numbers. So that is what is known as a dense set. And that is what is meant by countable and uncountable set. So what is a cardinality of a set? So again, what did we do today? So there are going to be sets which are going to be finite and infinite. And then infinite is countable and uncountable. So I'll give you a very beautiful example. For example, you have a jar of sugar. Okay. There are sugar granules in it. Okay. So no matter how many granules are there, you will always be able to count it. Okay. Because you can pick one granule, separate it out, then pick another granule, separate out, then pick another granule, separate out. So that jar of sugar consisting of sugar granules is a countable set, no matter how difficult it is, but you can count it. Okay. But if you grind that sugar into a mixer, then you will never be able to count it because now everything is mixed and everything is so dense that you will never be able to pick up and enumerate. So that is the difference between countable and uncountable. For example, hair on my head. Now, it is a very unnecessary or irrelevant task, but suppose I want to spend my 1 month counting the number of hair on my head, I can do it. Why? Because I can enumerate my hair strands. So the set of hair on my head is a countable set. Okay, the set of stars in the sky is a countable set. So you will say, how foolish can we be? How can we spend our entire life counting the number of stars in the sky? The difference is countable and uncountable. They are infinite, but they can be counted. Okay, but things which are infinite, but there are things which are infinite, but they cannot be countable. So that is the basic difference between a countable and an uncountable set. So I hope that now you are clear with the cardinality of a set: finite set, always countable; infinite set, categories, countable and uncountable. Countable sets can be enumerated, the elements can be enumerated. Uncountable sets can never be enumerated. So this is about cardinality of sets, countable and uncountable. I hope you enjoyed the class. See you in the next class with a more interesting topic.